Let's take a look at section 5.2 where we want to factor trinomials of the form x squared plus bx plus c. A prime polynomial is a polynomial whose only factors over the integers are one and the polynomial. When we factor a polynomial completely, it is written as the product of all prime polynomials. So let's look at our process for factoring x squared plus bx plus c. We want to find two integers n1 and n2 whose product is the term c and whose sum is the coefficient b. So n1 times n2 is c, and n1 plus n2 equals to b. So step 2 is to write the trinomial in the factored form x plus n1 times x plus n2. We're going to check the answer by multiplying out the factored form. So let's use this on x squared minus 16x minus 60. So n1 times n2 needs to equal 60. n1 plus n2 needs to equal negative 16. So we're looking for the two numbers that multiply to give 60 and add to give negative 16. So first of all, they both have to be negative to multiply to give a positive and to add to give a negative. And it turns out they're negative 10 and negative 6. Those are our two numbers, n1 and n2. So the second step is first to write this in factored form. X plus n1 will be x plus negative 10, which we can write as x minus 10. X plus n2 will be x plus negative 6, which we can write as x minus 6. And let's check this by multiplying out this factored form. We're going to use the distributive property twice. X times x minus 6 minus 10 times x minus 6 is x squared minus 6x minus 10x plus 60. So we're going to combine the like terms, and we get x squared minus 16x plus 60. All right, so let's factor this trinomial. Notice that our coefficients are still 1, negative 16, and positive 60. So we're going to get similar results to what we got above. But instead of getting x minus 10 and x minus 6, we're going to get, we need the middle terms to be xy and the final term to be a y squared term. So this then will need to be x minus 10y and x minus 6y. So when we check it by multiplying, we use the distributive property twice. X times x minus 6y minus 10y times x minus 6y gives me x squared minus 6xy minus 10xy plus 60y squared. And when I combine my like terms, negative 6xy and negative 10xy, I get x squared minus 16xy plus 60y squared. And that checks out to give what I began with. All right, let's continue looking at factoring. But remember, one of the things we always want to do first is look to see if there's a GCF we can factor out of every term in the polynomial. So notice 232 and 120 are all divisible by 2. And then every term has an x in it. The lowest power to which x ever appeared is 1. So x to the first power is the variable part of this GCF. So 2x multiplies by, I'll put that in red. So 2x is our GCF, and that multiplies by x squared to give 2x cubed. It multiplies by a negative 16xy to give negative 32x squared y. And it multiplies by positive 60 y squared to give my last term. So instead of writing this common factor 3 times, let's use the distributive property in reverse. So 2x gets multiplied by x squared minus 16xy plus 60y squared. And notice how that's the exact same polynomial we just factored. So 2x times x minus 10y times x minus 6y. And notice my monomial factor always is written first. And in this case, that's 2x. And then I write the binomial factors afterwards. So the factor with one term, that's 2x, is written first, and my two factors with two terms are written after that, x minus 10y and x minus 6y. So I want to look at my trial and error strategy. I'm going to find all pairs of factors for the leading coefficient a, and then all pair of factors for the constant term c. And by trial and error, I'm going to check all possible combinations of factors from step 1 and factors from step 2 that and until the correct middle term is formed by adding the outside and the inside products. If no such combination exists, the trinomial is prime. And then, of course, I check my answer by multiplying. So let's look at factoring this polynomial where a is 3. The factors of that are just 1 and 3. And c is 5, whose factors are just 1 and 5. So this is easy because these a is prime and c is prime, so there aren't a lot of factor options. So I can do 3x and x as my first terms, and plus 5 and plus 1 is my last terms. Now notice, I know first time first is 3x squared and last time last is 5, but it's the middle term I have to check. Inside time inside gives me 5x. Outside time outside gives me 3x. And those add up to give 8x and not the 16x that I need. So let's switch this around. Let's write 3x plus 1 and x plus 5. So inside time inside is x, outside time outside is 15x, and these add up to 16x like I need them to. And in the first case, they only added up to 8x. So it turns out my factorization is 3x plus 1, let's check this, times x plus 5. So let's use the distributive property twice. 3x times x plus 5 plus 1 times x plus 5 is 3x squared plus 15x plus x plus 5. Combining like terms, I get the original polynomial. 3x squared plus 16x plus 5. So this checks out. So 3x plus 1 times x plus 5 is my final answer. All right, when polynomials are prime, I won't be able to find a combination of factors that multiply to give that polynomial. So notice here my a and my c are the same. So I tried 3x plus 1 times x plus 5, 3x plus 5 times x plus 1. We already know that this is going to give us the first term and the last term that we need, but the question is, are we going to get the middle term that we need? Well, we know that in the first case, product of insides is x, product of outsides is 15x, so those add to 16x. Second case, product of insides is 5x, product of outside terms is 3x. Those add to 8x. And those are our only possibilities. So 3x squared plus 14x plus 5 is prime. So notice that the coefficients in this next problem, 3, 16, and 5, are the same as a problem we did earlier. The only difference is the presence of y in our polynomial. So we know we're going to need 3x plus 1 and x plus 5, but the 1 and the 5 need to be multiplied by y. And notice that this does multiply to give my polynomial. So 3x plus 1y times x plus 5y. All right, let's look at factoring polynomials of the form ax squared plus bx plus c using the AC method of factoring trinomials. So here, as in the previous examples, a was not 1. So first we want to multiply a times c. We're still looking for two integers, n1 and n2, but this time they need to multiply to give ac and add to give b. So n1 times n2 needs to equal ac, n1 plus n2 needs to equal b. we're going to rewrite the middle term as the sum of two terms using the integers found in step 2. And notice those integers are going to be the coefficient of these two terms. I'm going to factor by grouping, and I can always check my answer by multiplying. So let's use this 5-step process on 5x squared minus 2x minus 7. And let's use the AC method. A times C is 5 times negative 7, which is negative 35. So I need two integers that multiply to give negative 35. And those same two integers have to add to give negative 2. And this turns out to be really easy. And actually, the 5 and negative 7 do what I need done. Those multiply to give negative 35, and they add to give negative 2. So this rarely happens where my A and my B are actually my two numbers. My A and my C are the two numbers I need. But notice what I'm going to do. I'm going to rewrite negative 2x as negative 7x plus 5x. And I leave the 5x squared and the constant negative 7 unchanged. I want to find the GCF of 5x squared minus 7x. Notice that that's x. And it multiplies by 5x minus 7. So I'm going to need a GCF of the last two terms that also multiplies by 5x minus 7 to give those two terms. So my common binomial factor is 5x minus 7. So this factors into 5x minus 7 times x plus 1. And then I can check this by multiplying. 5x times x plus 1 minus 7 times x plus 1 gives me 5x squared plus 5x minus 7x minus 7. 5x squared minus 2x minus 7 is my final answer. Alright, so we could factor 5x squared minus 2xy minus 7y squared using the AC method. But because these coefficients are the same as the coefficients of the previous problem, we know that we can use our previous result. So this factors into the previous factors were 5x minus 7 times x plus 1. Well, the change here is going to be that I get 5x minus 7y so 5x minus 7y times x plus 1y are my factorizations that actually multiply to give what I began with. So I need that y on each of the last terms. Alright, so let's factor trinomials. And let's look at the case where we have to factor out a GCF before we start. And we still could use the AC method. So I look at my coefficients and I see they're all divisible by 3. And they all contain a y. So 3y times 5x squared minus 2x minus 7y squared. The middle term should be an xy term. Alright, so we'll use our results from our previous work. That 3y is going to get multiplied by 5x minus 7y times x plus 1y. And that's my factorization. And I did use, in the previous problem, the AC method to find that. So that's our final answer. All right, we want to be able to use substitution to factor trinomials that are quadratic in form. So we'll write the variable part of the leading term as the square of the variable factor of the middle term. Substitute u for the variable part from the previous step. Factor the quadratic trinomial if possible. Substitute the variable factor for u in the factored form. Simplify the result if necessary. And you can always check your answer by multiplying out the factored form. So if we want to factor 5x to the negative 2 minus 2x to the negative 1 minus 7, let's do this using substitution. Well, first I want to write x to the negative 2 as x to the negative 1 squared minus 2x to the negative 1 minus 7. So we're going to let u equal x to the negative 1. We could use any letter in place of u except for x, since x is the variable of our polynomial. So I'm going to rewrite this as 5u squared minus 2u minus 7, since x to the minus 1 is equal to u. And we factored this already. So this is 5u minus 7 times u plus 1. And let's replace u with x to the minus 1. We always want to go back to the original variable. So 5x to the minus 1 minus 7 times x to the minus 1 plus 1. And if we want to write it with no negative exponents, this is 5x to the minus 1 is 1 over x, so this is 5 over x minus 7 times 1 over x plus 1. All right, and here's our final answer, no negative or zero exponents.